modern society, electricity had become the fundamental source for numerous sectors to function properly. Since the invention of incandescent light bulb in 1879 by Thomas Alva Edison, which relies on electricity to work, various groundbreaking discoveries have been introduced to the public, including the generation, transmission, and use of alternating current pioneered by Nikola Tesla in the late 1800s, which revolutionized the ways of how people lived thanks to the various applications of electricity. Electricity is mostly described by the movement of charges of electrons present in a wire, for example. It employs potential difference or voltage, which is the energy used between 2 points in a circuit to induce motion between electrons in a conductor that results in an electric current. The impact of electricity in the norms of living is known widespread, to the point where it could be said that society will not function without it. It is not an overstatement that electricity plays a pivotal role in our lives by becoming a pillar that is fundamental for every sector to function and develop. Nevertheless, it still possesses risks and dangers to human lives. For example, in June 18, 2023, there had been a report about an electrocution case of a lineman in Talisay, Cebu, Philippines. It is said that the victim had severe third-degree burns on both arms due to a high-voltage shock. The physiological effects of electricity vary from a minor shock to a severe one that can lead to death. When a person came in contact with 5 milliamps of electric current, his or her body will feel a slight shock that can cause involuntary reactions. As a chain effect, this reaction may lead to indirect injuries. Meanwhile, 6 to 30 milliamps will cause painful shocks that will numb the muscles, making a person lose control and freeze on the spot, thus staying in contact with the conductor for a prolonged period of time. This can increase the susceptibility of a person to sustain further injuries. Strong amount of electric current ranging from 50 to 150 milliamps will induce extreme pains and respiratory arrest. The muscles of a person will also be affected. Since this can stop the breathing and cause a lung failure, the death rate is probable due to critical damage in the internal organs. An even higher amount, ranging 1 to 4.3 ampere of electric current, can cause the fibrillation of the heart, muscle contractions, and nerve damages. This will also lead to death due to the grave injuries. For an amount of 10 ampere, cardiac arrest and severe burns will be sustained by the victim. In this case, death is also expected. Generally, electricity causes internal burns, arrhythmias, bradycardia, blood vessel injury, neurological injury, neuropsychological problems, and musculoskeletal system injury. The human body has a natural protection against electric shocks, which have a resistance ranging from 300 to 100,000 ohms. However, this amount is not enough to neutralize the electric current induced by an external factor. The neurons in our nerve system communicate with the body organs through small voltage electric signals. If this amount is suddenly increased, there will be an overload with each of the cells, causing the disruption with their normal functions. With this, precautionary measures should be strictly followed to avoid incidences that can endanger the lives of many. The engineering of various equipment must prioritize the safety from the electric current. This includes ensuring the use of insulating materials to avoid being in contact with conductors. Another important thing to consider is the proper placement of electrical systems in facilities and households. The wires containing the electric currents must be covered and placed in appropriate areas. Moreover, proper maintenance and regular inspections must be considered to ensure the improved safety of the facilities by identifying possible risks and issues that can pose dangers. Aside from those, being aware of the threats and hazards that electrical systems may have can significantly reduce severe and major incidents. So, for example, when fixing issues in circuits, one must ensure the blackout of electrical or power supply first. During emergencies, having knowledge for an immediate response must be practiced to mitigate and prevent worst-case scenarios. When dealing with electric circuits and wires, one must wear proper personal protective equipment or PPEs such as insulated gloves, tools, and helmets, as well as fire-resistant clothing in case of explosion to minimize the burns and damages. Electricity becomes a threat to us if we do not practice precautionary measures. Its physiological effects provide substantial information to how it cannot be taken lightly. in a society where electricity becomes the driving factor of development, it is crucial that people know how to properly deal with its hazard. Although it can be seen everywhere, the risks, dangers, and effects of electricity must not be underestimated and held with high regards instead.